ओके दोस्तों, तो ये क्वेश्चन हम देखते हैं. द क्वेश्चन इज गिवन एज फॉर अ सैंडी टाइप ऑफ सॉइल with soil grain spherical in shape and uniform in size. Means the soil is made up of soil grains which is spherical in shape. So this is, suppose this is the sphere, and the sphere is going to be uniform in size. Means all the particle, that is the soil grain of the sandy soil, is spherical in nature, and this sphere have the same dimension throughout the soil mass. So you again form one sphere. So these having the dimension of what, d. Suppose this is the dimension of d. So throughout the soil mass, all the soil grains have the same dimension, and that is of d. So it is spherical in shape and uniform in size. Now determine the maximum and minimum void ratio. So for a given soil mass, if you have been asked to calculate what is the maximum and minimum void ratio, so for that this question is there na. So what is void ratio? Void ratio is represented with E, and it is defined as volume of voids by volume of solid. So if you see the three-phase diagram of the soil mass, so suppose this is the soil mass, and we have the three-phase diagram like this. This is the soil solid. This is, suppose if soil have water, so this is space for water, and this is the air. So all the airs and waters will occupy the space of the voids. So this is known as the volume of voids, and the volume of the solid, the space which is occupied by the soil solid, is the volume of solid. So this is Vs. So void ratio is defined as volume of voids get divided by volume of solid. Okay. So we have to calculate what is the volume of voids and what will be the volume of solid. So when we have maximum void ratio, so maximum void ratio will be there when it has the configuration like this. Suppose a soil is going to be arranged like this. These are the soil particles, and if I am preparing the soil mass like this, so one over another soil grains are there. So in this case you will find that the voids are going to be in the maximum one. Okay, so for maximum void ratio you will find these are the voids. So in this configuration you will find that the soil mass has maximum void ratio. The soil mass will have maximum void ratio. So this configuration is in elevation. This configuration is in elevation. If I have to plot the plan, means for this soil, plan and elevation is going to be the same one. If we consider this as this configuration as plan, so it is okay, and if we consider this configuration as elevation, so it is okay. So for maximum void ratio you will find that the configuration of the soil grains that they have packed, they will be similar in elevation as well as in plan. So if we have this center of the soil, and if we arrange, you will find it will form a cube. This will be a square, and when you will imagine this configuration in 3D space, then you will find this as a cube one. Okay? So in maximum void ratio, this is going to be the configuration one. Similarly, you will find that one sphere is there I will show you the configuration, how this configuration will look like in 3D space. Now comes to the minimum void ratio. When you have the minimum void ratio, then how will the configuration look like? So in case of minimum void ratio, these soils that you have seen will move to these soil will move to occupy these space of the voids, so that the soil have minimum void ratio. Just see the configuration in the elevation one. We have, like, this is the first layer, this is the second layer, and this is the third layer. So I am drawing first the first layer. So these are the first layer. Now second layer will be not just above, means when maximum void ratio is there, then soil grain is just above this one. But in this case, the soil will occupy the void space. Like the second layer will be at this position. And where will be the third row? So third row will occupy these positions. So in this configuration you will find that the void ratio is going to be minimum 1. Okay, so this will be in the elevation. In plan you will find that the figure is going to be look like this. Suppose I am drawing one soil here, so I have drawn the first layer. So this is the configuration of the first layer. This is the configuration of the first layer. Now I am placing the second layer. So I am placing the second layer, then you will find that this is the second layer which is just above at this point. Means the second layer is nothing, second layer is placed like this one. So second layer is going to be like this. This is the second layer. Okay. Again the third layer is going to be, you will find that third layer is somewhere here. So it will repeat. The first layer, this first layer will repeat itself, and the third layer will become equal to the first layer, and the second layer is totally different. So the configuration you will find somewhat here, like you have studied the type of unit cell. So I am taking these 4 sphere, these first sphere, second sphere, third sphere, fourth one. These are the configuration that, suppose this is going to show you the second layer, and these 4 spheres will show you the configuration of the first layer. So you will find that this second layer sphere is just above the first layer. This second layer sphere is just on first layer. So it will form a simple cubic configuration, and it means this will represent you the maximum void ratio. This will represent you the maximum void ratio. And when we have the minimum void ratio, means we have the configuration will be looking like this. The face centered configuration is for the minimum void ratio. So the configuration in 3D will be looking like this one. Now for calculation of the void ratio, means you want to calculate what will be the void ratio. So for calculation of the void ratio, you have to pick first, for maximum void ratio, means simple cubic arrangement. So I am first calculating maximum void ratio. maximum void ratio. So for E max, we have to choose the simple cubic configuration. So I have taken this figure. I have taken this figure, and you will also find this figure. If you will, if you match the center of these spheres, then you will find the figure is looking like of this one. So you will find that I have taken the 1/4 portion of the, yes, 1/8 portion. 1/8 means a sphere is get divided into 8 part. So I have taken the 1/8 portion of a spherical soil grain. So in this way I have taken already 8, like this one is first, this is second, this is third, this is fourth, this is fifth, this is sixth, this is seventh, and this is 8. So I have taken the 8 sphere, like we have taken 8 sphere, we have the 8 sphere, so we have taken 1/8 of each sphere. So here we will find that we have the 8 part of different spheres. So if we mix all the spheres, all the part of the spheres, then we have only one sphere. If we mix all the sphere parts, then this will form a complete sphere. Okay, so suppose I am taking this dimension as A, like I have denoted here with D na. Here I have denoted this as diameter as D. I have denoted the diameter as D. So forget this A. This A is for representation purpose. Like here we have the half of the diameter, so this is going to be D by 2. Here we have the half of the diameter, so the dimension is going to be D by 2. So we will find that a side of a cube is of D dimension. Size of the cube is of D dimension. So I want to determine what is the void ratio. So for determining the void ratio, you will just have E is equal to, I just pick this figure to downward side now. So for E you have to determine what? Volume of voids by volume of solid. So first I determine what is the total volume. If I have to determine what is the total volume of this one, the formula is going to be the total volume. Total volume is going to be dq, because we have already find that the side of this cube is d by 2 and d by 2. So total side is of length d. So the volume is going to be dq. Now I have to determine what is the volume of solid. Means the solid grain we have to determine what is the volume. So we have taken the 1/8 of each sphere, 1/8 part of each sphere, and we have the total number of sphere is 8, so I just simply multiplied it with 8. So we have one complete sphere. We have one complete sphere. One complete sphere. And you know what is the volume of a sphere. So just determine what is the volume of the sphere. So volume of the sphere is going to be what? Pi into dq by 6. This is the volume of the sphere. So this cube is made up of 8 different sphere, and each sphere contributes its 1/8 part. So so you just simply assume that this is made up of one sphere. So volume of the sphere is going to be pi dq by 6. So I have to determine the E max. So E max is going to be volume of voids by volume of solid, and this is nothing but total volume minus volume of solid by volume of solid. Because here we can see that now in this figure that we have drawn, this Vs plus Vb will equal to the total volume of the soil mass. This is the total volume of the soil mass. So total volume of the soil mass is Vb plus Vs. So I have to determine what is the volume of voids. So this is simply V minus Vs. That I have written here. That I have written here. So this is total volume minus volume of solid get divided by volume of solid. Total volume is nothing but dq, and volume of solid is pi into dq by 6 get divided by pi into dq by 6. So you will find that this value comes out to be 0.91. Okay, so you will just you will just find that what is the maximum void ratio for a sand in loosest state. Obviously you will, if you have the maximum void ratio, means that soil is in its loosest state. So Emax for a sand is going to be 0.91. Okay, now we have to calculate what is the void ratio in denser state, that is E minimum. So just see this figure na. When you have to determine the E minimum, that configuration will be looks like a face centered configuration. So in this face centered configuration, if you take the unit cell, then what will happen? This unit cell will made up of 4 different sphere at the corners. So 4 different spheres are at corners, and 4 different spheres that is packed here. These are the 4 different blue color that you have seen. They have packed the space. So in this in this face centered, if we try to form a sphere, then this sphere will be looking like this. This sphere will look like this one. So you will find, just connect this figure to this one. You will have one sphere here. So suppose this is one sphere. So first sphere is this one, second sphere is this one, so second sphere is this one, third is this blue color. Blue color is going to be shown like third. So third will contribute its half part to the unit cell. So half part is there. Then again we have the fourth one. So this is fourth one. This is fifth one. So this is fifth one. Then this sixth. Then this sixth. Then this seventh. Then this seventh. Like similarly 8 and 9 is somewhat there. 8 and 9 is somewhat backward. Then we have the 10th, 11th, 12th and 13th and this 14th. So we have this and another is that one, and one will be just opposite to this sphere. This half sphere just opposite to this one. So if we contribute how much the sphere is contributing to the this unit cell, then we will find that we have 4 different one. These part are 1/8 part of one sphere, and this is the half part of the sphere. So for making one complete unit cell, how much sphere is there? So you will find that there are how much sphere? 4 is on upside, 4 is on downside. So you will find that total number of sphere is going to be 8 in this case. So we have the 8 such different sphere which is contributing its 1/8th part, and 4 such sphere, these half sphere you are seeing here. I just change my color. You will have 4 different sphere, first one, second one, and 2 are on the opposite side. two are on the opposite side. So this sphere is 4 and it's contributing its half of the part. So 4 into 1 by 2 plus one is at bottom and one is at, means one is at top and one is at bottom. So two sphere is there and it's also contributing its half. So total number of sphere is 4. So for forming this configuration, we required 4 different sphere for forming this. So I just take this figure to downward direction for calculating the void ratio. So for E minimum, I again calculate what is the volume of voids by volume of solid. Okay, so just see how we can form the diameter. Like we have this diameter, so this is going to be d by 2, this whole is d, and again this is going to be d by 2. So if we have this diagonal is of length what, 2d, and we have to calculate the length is of this one. This a is representing your length, so a will be nothing but 2d 2d of cos 45, like that, cos 45 or cos sin 45, like that. So this is 2d by root under 2, so this is nothing but root under 2d is the dimension of this unit cell. This side is of root under 2d unit. Okay, this side of the cube is going to be of root under 2d. Okay na, because this is 45, so you will have the idea. Now I have to calculate what is the total volume. So total volume is going to be what, side square. So I am just writing to root under 2d whole cube. And I have to determine what is the volume of solid. So volume of solid is going to be like the volume of one sphere. Volume of one sphere multiplied by total number of sphere. Forming this cube. So volume is going to be volume is going to be pi into d cube by 6, and total number of sphere is going to be 4. That we have already calculated. Na? We have already calculated that total number of sphere is 4, that is used to form this unit cell. So 4 is there. Just I will calculate this one. So E minimum is again what? Volume of voids by volume of solid. This is nothing but total volume minus volume of solid, get divided by volume of solid. Total volume is root under 2d whole cube minus volume of solid is nothing but 4d cube by 6, and this is 4 pi d cube by 6. If you calculate the volume is going, the void ratio is going to be 0.35. So you will find that for a sand which have uniform sphere, means soil grain is of uniform sphere shape, and all the soil grains are equal in dimension, means all the spheres are having the diameter of d only. So for that case you will find E max, that is in loosest state, and this comes out to be 0.91. E minimum, this is in dense configuration, and for that we have the void ratio of 0.35. So this is the answer of the problem that we have seen here. This is the answer. Okay, now we will come to the question number 2. And these all questions are from the Gopal Ranjan book, so you may refer the book also. So what is the second question? Second question is telling like we have 1 meter क्यूब ऑफ वेट सॉइल, वेट सॉइल वेइंग कितना है, वेट्स, its weights is 20 kilonewton, 20 kilonewton. Its dry weight is 18 kilonewton. And we have the specific gravity, specific gravity of solid is 2.67. So determine the water content, porosity, void ratio, and degree of saturation, and also draw the phase diagram. So in this question you will find that what is given. So we have a wet soil, means soil is given which is wet. So wet doesn't mean that the soil is going to be fully saturated or like that. Wet means we have the soil that may be partially saturated or like that. Na? So 1 meter cube of a wet sample is there and its weight is 20 kilonewton. So what is given? Weight of the sample given, and this is 20 kilonewton is there. What is the volume of the sample? Volume of the sample is 1 meter cube. So this is the weight and the volume of the soil mass. This is weight and volume of the soil mass. And here it is given that its unit weight, its dry weight is 18. So weight dry means weight so dry weight is 18 kilonewton. Okay, means this weight does not have the influence of water, means water weight we have neglected here, but here this weight is of wet soil. So we have the weight of the what, grain, as well as weight of the water. So if we can see the configuration of these two, I am drawing the phase diagram here. So in this phase diagram, I have assumed that soil is going to be partially saturated. This wet soil means soil is, I am assuming here, this soil is partially saturated. That will be confirmed after when we determine different this water content, porosity, void ratio, and degree of saturation. When degree of saturation we will get, we actually comment upon the state of the soil. Right now I am assuming that wet soil means this is partially saturated. Means partially saturated means we have solid, we have water, and we have air. So this wet soil is made up of solid, water, and air. Now total weight is given as 20. So you know that air do not have any weight. This weight is due to weight of water and this weight is due to weight of solid. And summation of these two is going to have 20 kilonewton. And here volume is 1 meter cube. Volume is 1 meter cube. Now in the second part, like we have the dry weight. Dry weight means this soil, when we put it into the oven, the soil gets dry and the volume of the soil will remain same. This volume is going to be remain same. So 1 meter cube volume is there, but soil have what? Only solid and air. Now water has been evaporated out. Why? Due to as we have put that soil into the oven. So solid weight Ws, because air weight is not, 0. So this Ws is nothing but what? 18 kilonewton. So it is given as dry weight. Means when you will find that there is a dry weight, that means the weight of the solid. It represents the weight of the solid only. Okay. When we have this soil as weight is 20 and 20 kilonewton, and this is wet soil, so here we will find that weight of water plus weight of solid, this is going to be the 20 kilonewton. Okay. So here we have find that weight of solid is 18. Okay. And here we have find that WW plus WS, like WW plus WS is equal to 20, and here the value of WS is equal to 18. So we can find what is WW, and WW is nothing but W 20 minus WS, and 20 minus 18 is going to be 2. So weight of water is going to be 2 kilonewton. Now we have to determine the different quantities like water content. So you will just remember, you have to remember that what is water content. Water content is weight of water by weight of the solid. Now both the things we know, like here weight of solid is 18 kilonewton, weight of water is 2 kilonewton. So we just simply 2 by 18 and it multiplied with 100 because water content is in percentage. So this comes out to be what? What will be the value? This value becomes 11.1%. So this is the answer. What water content is 11.1%. Now this is the first subsection that I have determined. Now second one that we have to determine is the porosity. And this is denoted with N. And what is the formula of porosity? This is the volume of voids by total volume. Okay, this is the volume of voids by total volume. Now I have to determine what is the volume of voids. Okay, and I have to determine what is the total volume. But in the question, total volume is given. Total volume is given. This is 1 meter cube. So this is nothing but V. But I have to calculate what is volume of voids. Now, if you see the figure, okay, here you will find that this is the volume of solid, this is the volume of water, and this is the volume of air. And summation of Vs plus Vw plus Va is equal to 1. This is the summation of the volumes, different volumes. So volume of solid, volume of water plus volume of air is going to be 1. Okay. And you will find that Vs and these two volumes will becomes equal to Vb, and this is 1 because volume of voids in voids volume, air and water gets entrapped. That's why these two represent the volume of voids. So these are the volume of voids. So volume of voids is nothing but volume of water plus volume of air. Now we have to calculate what is the volume of solid. Then after we can use this expression to calculate what is the volume of voids, or we can calculate volume of voids directly. So let's see how we can calculate these one of these parameters. Means in these two, from these two parameters we have to calculate only one. So it is easy to calculate what is the volume of solid. So how we can calculate the volume of solid? Just refer the question. In question, a specific gravity is given. So if the parameter is given, that is connected with some of the that is connected to some of the solution that we can get from this parameter. So a specific gravity is given, and if you recall, what is a specific gravity? GS. A specific gravity is nothing but weight of solid by volume of solid into gamma W. So this is the specific gravity. So I just know what is the weight of the solid. Weight of the solid is nothing but 18 kilonewton. You will have this weight of solid as 18 kilonewton. So I just put here 18. I do not know what is the volume of solid. I know what is gamma W. Gamma W is 9.81. Okay. And this all equal to the GS, and GS value is 2.65. That is given in the question. 2.67. Sorry. 2.67. Now from this equation we can easily calculate what is Vs. So Vs is nothing but 18 get divided by 2.67 multiplied with 9.81. This is Vs multiplication. So from here we can calculate what is Vs. So Vs comes out to be what? 0.6879. 0.6879 meter cube. Okay, because gamma W is also in, I have assumed gamma W is equal to 9.81 kilonewton per meter cube. So volume of solid we obtain from this expression, and this volume of solid is 0.6879. Now for porosity, what is there? Volume of voids by total volume. Now I have calculated this volume of solid. So volume of voids can be written as total volume minus volume of solid, get divided by total volume. Now total volume is 1 minus 0.6879, get divided by 1. So what is volume of this porosity? So this porosity will become, and we know that porosity is always expressed in percentage, so I have to multiply it with this 100. So throughout this expression I have to multiply it with this 100. So this comes out to be 31.21%. Okay. Now the third part we have to determine as what is void ratio. Third part we have to determine void ratio. So void ratio is represented with E, and this is nothing but volume of voids by volume of solid. All the data I have calculated. What is volume of voids? This is nothing but V minus Bs by Bs, and this is 0.6879, get divided by 0.6879. So the answer comes out to be what? 0.45. And this void ratio is expressed in percentage, expressed in decimal form. So this is the correct one. Now the fourth one. Fourth one, what? Degree of saturation. Degree of saturation. So how we can define this degree of saturation? This is represented with capital S, and this is volume what? Volume of water. Volume of water by volume of voids. Now we have to calculate what is the volume of water. Okay, and from there we can find what is the degree of saturation. Okay, so we can also use one expression for degree of saturation, because we do not have the idea about volume of water here. Okay, for volume of water we have to determine what? Like volume of water is equal to weight of water by gamma W. So one formula is there, like weight of water is 2 kilonewton, and this again is 0.98. So what is the value of volume of water? So you will find that this is equal to 0.2041. Okay. Now this is there, and volume of voids we have already calculated as 1 minus 0.6879. So this is what? 0.3121. 3121. So we can use saturation, and it is expressed in percentage, so you have to show we have to multiply it with 100. So S is going to be what? 0.2041, get divided by 0.3121. Okay, so this comes out to be what? Multiplied with 100. So this comes out to be what? 65.4%. Okay, so degree of saturation is 65.4%. That means soil is, this indicates soil is partially saturated. Soil is partially saturated. Okay, so my assumption is correct, and the three-phase diagram will be looks like this one. Okay, so I have to draw the three-phase diagram because in the question it is asked, and I am just telling na, you can easily calculate this void and this degree of saturation using this formula. Like we have one formula na, E into S is equal to GS into water content. We know what is the value of GS, that is 2.67. We know what is the water content. Water content is what? how much? 11.11. 11.11. So water content is 0.111, and E I have calculated E 0.45. Here directly we can find what is the value of S. So the question can be solved in different ways depending upon what formula you know. So I can also calculate this question, this degree of saturation from this equation also, and this again comes out to be like this 0.654, and in percentage it is 65.4%. So the question can be formed, can be solved in different way, depends upon what you have remembered and what concept just clicked, what concept that you remember at that time. So the three phase diagram will be shown like this. Soil will be soil is going to be partially saturated, so its contains soil solid, it will have water, and it will have air. So this water weight of water is going to be 2 kilonewton. This weight of solid is going to be 18 kilonewton. Now what will be the volume of solid? Volume of solid is going to be what? 0. What we have calculated? Volume of solid 0.6879. So volume of solid is 0.6879 meter cube. Volume of water that we have calculated, how much it comes? Here we have calculated na? Yeah, 0.2041. 0.2041. So volume of water is going to be 0.2041 meter cube. And what will be the volume of air? Volume of air is equal to, total volume is 1 meter cube minus 0.679 minus 0.2041. So this is the volume of the air is there. So you can easily plot, easily draw this three phase diagram of the soil. So for this class I just stop here. In the next one we will discuss some another question, and in this through this channel I will just solve different types of the questions. Okay. Okay.